In this video, I'd like to demonstrate how to design spread footings in RISAFoundation. We'll start off with a moment frame here in RISA 3D with some loads applied. So if we're looking at the loads here, I have some dead loads and live loads, a variety of different wind loads applied to the structure. And we're going to just run a batch solution. So I'm going to solve the envelope with the batch, and it will run through all the solution, give us results based on the joint reactions of the loads applied. And these are our envelope solution. The important piece when you're in RISA 3D is to figure out here, if we go to our basic load cases, is to use these categories. So right now I have dead load, live load, and wind load. These will be carried over into RISAFoundation. So you need to make sure you define categories. We can use the director button at the top right corner and take all the information that we've done here in RISA 3D over to RISAFoundation. As we bring it over, we pop in and we see that we now have all those joint reactions listed here on our screen. Based in the same categories I mentioned, so dead load, live load, all that information is there, brought for you automatically. And the load category spreadsheet, if you open that up, you can also review it in the point load spreadsheet here. So you just click on that number 4, grayed out, and you'll see all the different loads that are coming across from RISA 3D based on the different types of categories that we have. So I'm going to close that down. The first thing before we put our spread footings in, let's just review the footing definitions. That's on our data entry toolbar here. If we click on footing definitions, I start out with my general tab, and I can see there's some information on the screen for the general parameters. So minimum and maximum steel ratio here, so our row, as well as the material we might want to use. So we have a variety of different materials as our defaults. If you want to add to that list of materials, there's a materials spreadsheet you can open up here, and you can add to this materials spreadsheet. For the design roles here, we'll come back to that in a second. That's going to be some of our reinforcement information. We can tell the program here to do some equal bar spacing, to group the design. So if one footing is going to be controlling, it will actually design all the footings the same. If we're going to do any concrete bearing checks, if we're going to force this to have top reinforcement, we'll leave those settings there. I'm going to go over the geometry tab. The geometry tab tells you the size of the footing. So the program in RISAFoundation is going to be designing this footing for the size needed. So it's going to start at a size 2 foot length here and width, and then it's going to grow that incrementally. And there's the increment here, so it's going to grow by ½ a foot until it meets the demand of the footing. We have a minimum and maximum thickness, and then we also have an increment there. You can also force the program to do a square footing if that's helpful for you. Probably less concrete if you don't force it to be square, so I'm going to leave that off. We can go over to the pedestal. So there is by default a pedestal on this. If you do not want a pedestal, you can just take the height and make it 0. Otherwise, you have a pedestal, and you can change the size there. We'll leave it at 12 by 12 with a 24-inch height. The pedestal also can be offset, so we can use a boundary or eccentrically moving that so it's not at the center of the pedestal, is at the center of the footing. If you want to do that eccentrically, you just enter in your eccentric boundaries here, or you can say it's a boundary, like if you have a property line and that's a bound on the edges. We also can change the soil properties here. So right now we have an overburden assumed on top of that footing. We don't have any passive soil for sliding resistance here, but there is the friction coefficient, and we can tell the program whether we're deciding that that's going to be gross or net bearing. I'm going to close that down, and let's jump back to the design rules. So if we're looking at the design rules, that's on our data entry toolbar. There is a footing tab here. So the program is currently using number 3 bars for the top and number 4 bars for the bottom. The pedestal here are going to be number 3 bars. So this is a nice smaller size framing. We might need to increase that if we don't meet our demand, but we'll leave that as it is. In order to draw the footing, the best way to do that is just to turn our graphical editing toolbar on, and we can see here there's a dialog here, an icon called Assign Footings. We click on that, and that's our footing definition that we just have here, footing 1 that we just reviewed. And we could change the angle of it. Ours will be square. That seems pretty realistic for us, so we're going to say Apply, and you just box or click on the node that you want the footing. And zoom out there, you'll see there's just a default size that comes in, and then we can start to apply those loads. So the loads are already in our load category spreadsheet. Now we need to create some load combinations. If we bump into the load combination spreadsheet here, we have a variety of different load combinations. Let me show this by demonstrate this. I'm going to delete all of our load combinations that we have in here by default. We'll create our own from scratch. So load combination generator, if we come in here, we have the ability to do different regions. So United States we'll stick with here, but we have different regions, strength, ASD. So maybe for our service combinations for bearing and for stability checks, we're going to just create a whole series of ASD different ones. And I'm going to say this is going to have wind load in the 2D direction because we're using WL, and it's going to be reversible. So you generate, and when I create those, you'll see that I have a list of service checkbox turned on. That's for our ASD. And then the next piece I'm going to do is my strength one. So I'm going to click on load combination generator, and I'm going to use the IBC as 2012 strength and generate those. And then I see that the service checkbox is not turned on for those. I'm going to close this down, and we can now run all of those different load combinations. In RISAFoundation, it runs an envelope solution by default, so you're all set for an envelope solution. And we can take a quick look at our results. If we go to our results tab here, we have footing results, and it opens up and we see that we have a footing with the length being 2 feet and the width being 6.5 feet. The thickness is going to be 12 inches. So if we look at our steel reinforcement, it gives us a breakdown of what the steel ratios are here. We go to the footing code check. We see all of our information for the code check. This is a really helpful tool, but I really like to see more than a spreadsheet. A spreadsheet's really good for understanding the tally of what's happening in the entire project. But if we're looking at a single footing, I like to look at the detail report. So I'm going to click on that detail report. And this gives me more of a breakdown of exactly what happened for the calculations. I can see the footing drawn in sketch. I see all of the reinforcement drawn out. So I'm seeing all of that listed there. And we scroll down below that, the geometry is broken down with all the loads that went into this footing. It gives us a soil bearing check, and we're seeing all blue numbers here. If we were seeing any failures, they would turn red. So everything is adequate for the size we have right now. It gives us a nice breakdown of the diagrams, and below that we see all the steel. The green numbers here are going to be some of the controlling values for the entire footing. So we see that this combination was what was controlling the dead load with the wind. And we'll scroll down below that. We see the footing checks are listed here, top bar check, the shear check. We're doing a two-way and a one-way shear check, and that all looks good. The pedestal is being designed. We're looking at number 3s at 4 inches, so a little tight. Maybe you want to bump that up, but that's probably okay for now. And we scroll below that. Now, one thing I am seeing is I'm seeing some red numbers in the overturning checks and the sliding checks. So these checks are going to be showing me that the program is saying it's not being fully adequate for this size footing. If we go to our global parameters, we have some information here to check on. So the program right now is not optimizing that footing for overturning and sliding. It's just designing it for all other of the parameters, but it's not making it a larger footing for that. So let's try to make that so that the program will actually size this a little bit larger, and this will work for overturning and sliding. So I'm going to check that and say OK. The solution is going to be cleared, and I'm going to rerun the solution, and now I see a slightly larger footing there. I'm going to click on that footing again, and we see now it went to an 8.5 by 12. So it's a larger footing, and it's really that we're now trying to conquer that overturning. So I'm going to go all the way down here and see what happened on that overturning. So yep, we've got it overturning now. Everything is adequate. There's no more red listed in there, and my sliding is also okay. All my ratios are working on my sliding. So this is going to be our footing design. We can see footing design based on each one. We can go to the next one. It's going to be very similar. They're pretty much identical. If you ever wanted to say, take a look at this footing and see maybe why the 8.5 by 12 worked, maybe we can see if a 8 by 12 foot, or maybe even smaller than that. There's a redesign button at the top right corner, and you can check by sizing this down. So maybe an 8 by 8. How come maybe that would work better for us? And we can change the thickness possibly, maybe to an 18 inches. Say OK, and then that footing then gets rerun using the results we have there, and checked for what we just entered in for the size. So it still looks okay for flexure. Looks like my shear checks are going to be okay. We would probably wonder if our overturning is okay, and maybe we see that our sliding is not going to work for that one. So maybe there's ways you can handle that. but it's a good tool in order to recheck different sizes. Thank you for watching this video on RISA Foundation. Visit www.risa.com for more information on RISA Foundation.